This video is going to take a look at a special type of discrete distribution called the binomial distribution. And the binomial distribution helps us calculate what is the probability of x successes out of n trials. In other words, I'm going to conduct a survey, and maybe I want to see how many people support a particular political candidate. I want to know what's the probability that 100 out of 200 of them, or 50%, support my candidate. That is what we call a binomial distribution. And a binomial distribution has the following characteristics. First, there is always a fixed number of trials. I'm going to interview a certain number of people, or I'm going to run a test a certain number of times. And when I run that experiment or that survey, there are really only two options. The two options are success, and we usually use x to represent the number of successes, or failure. And it's important to note, as we define success and failure in our experiment, there is no moral or good-bad judgment to the word success. And quite often, success is a bad thing. If I'm in quality control, I might say a success is a defective part, and we're looking at how many successes there are. In that case, success is a bad thing. So there's no moral or ethical standard for success. Success is just what we are looking for. So try to avoid pinning positive and negative emotions to that word. With those two options of success and failure, we'll often talk about P, which is equal to the probability of a success. And if x is the number of successes, and we'll use n for the number of trials, x divided by n would be the probability of that success. Then we also have this letter q, which is the probability of failure, the opposite. And since there's only two options, success and failure, we can quickly calculate q to be equal to 1 minus the probability of a success. It's the complement. So the distribution itself the distribution for the binomial is, we're going to say that x tilde, or the little squiggly line, b for binomial, and then in parentheses we'll do n, the number of trials, and p, the probability of success. And we'll use this notation to represent how the x is distributed. It's distributed as a binomial with n trials and a p probability of success. And if we are in the context of the binomial, we have some shortcuts to help us calculate things like the expected value. The expected value, or the mean of the distribution, is simply going to be the number of trials times the probability of success. And that seems to make sense. If I have 30 trials and a 10% chance of success, I would expect to be successful 10% of 30, or 3 times. We can also use a shortcut formula for the standard deviation of the binomial. And the standard deviation, or sigma, is equal to the square root of npq. Now, we could go through the formulas for mean and standard deviation like we did with just the generic discrete probability distributions. It just gives us the same answer, so we might as well use this nice little shortcut. And actually, before we move on, let's go ahead and highlight these 3 pieces, because these 3 pieces are foundational to doing our binomial distribution. Let's look at using the binomial distribution. And you notice I never gave the formula for how we actually calculate binomial probabilities. That's because we're going to cheat, and we're going to use the calculator to do all the work for us. In the calculator, the steps that you're going to push on the TI-83 or 84 calculator is you'll hit the second button. And then you're going to hit the what's called the distribution button, which is above the button that actually says vars. So when you hit the second, it gives you the command above the button. The distribution function is what we want to use. And we're going to use the binomial distribution. So then we will scroll down, and there's 2 options for the binomial. The first option is called the binomial PDF, and it opens a parentheses. That one gives us the probability of exactly x successes. The one below it we'll also use is called the binomial CDF. And the C in there stands for a cumulative distribution function. That tells us the probability of up to and including x successes. In other words, with the CDF, if I'm interested in the number 3, if I want 3 successes, the PDF will tell me exactly 3 successes. The CDF will tell me what's the total probability of 3, 2, 1, or 0 successes. All the probabilities up to and including that number. Now, after the parentheses, we do have to enter in the key information. Some calculators have some software that it'll prompt you for the information. But if it doesn't prompt you, you just need to know that the format for both of these is exactly the same. We will use the binomial, and I'm going to do a star because it could be the PDF or the CDF. Both of them are the same. Then the first number you enter will be the number of trials, comma. The next will be the probability as a decimal, comma. Then you'll do x, or the number of successes, and close the parentheses. And that's how we can use the binomial distribution on the calculator. And it's probably easiest to see with an example. And according to the website citydata.com, in Moses Lake, 7.9% of workers carpool to work. You're going to go out and you're going to conduct a sample of 41 workers. First thing we want to do is identify what is the distribution. For this situation. The distribution of our x, or our random variable, is going to be randomly distributed as a binomial. So we'll do a b, because we're looking at the number of successes out of these 41 trials. The first number is the number of trials, 41 trials. The second number is the probability of success, which is 0.079. We do need to change that percentage into a decimal. So of our 41 workers, how many would you expect to carpool to work? Well, when we're looking at how many would we expect, we're talking about the expected value, or the mean. The mean, we said, is equal to the number times the probability, or the 41 people you surveyed times the probability of 0.079. That gives us an expected value of 3.239 workers. So maybe you'd round that down to 3 workers. You'd expect about 3, maybe 4 out of your 41 workers to carpool to work. Let's scroll up. We'll come back to the calculator strokes in a minute. What is the standard deviation? Of our population? Well, we have our formula for the standard deviation. It's the square root of NPQ. So we'll take the square root of n, the number of trials is 41. P, the probability is 0.079, times Q. Well, Q is the probability of a failure, or the probability of someone not carpooling to work. Well, if 7.9% carpool to work, we can do 1 minus 0.079 to get Q is equal to 0.921. So Q is 0.921. And when we multiply and take the square root, we'll get a standard deviation of 1.727. But we still haven't calculated any probabilities. So let's do 2 or 3 of these. Let's say, what is the probability exactly 3 of 41 carpool to work? In other words, what's the probability that our x, our number of successes, is exactly equal to 3? Well, because I'm looking for a specific exact number, that is going to be the PDF on our calculator. So on our calculator, we're going to do the binomial PDF. And then we do the number of trials, the probability of 0.079, comma, the number of successes we want, which is 3. Let's go to the calculator and do that. On my calculator, we said the way we got the binomial PDF is we hit the second button, and then above vars, you see the word distribution. Now, the binomial PDF is near the bottom, so you can scroll down a bunch, or if you scroll up once, it'll take you to the bottom. And you see options A and B are the binomial PDF and the binomial CDF. I'll hit enter on the PDF. Now, mine gives me the prompts, so I just have to enter in the number of trials, 41, P, the probability of 0.079, the x value, the number of successes I want, which is 3, and then I can select paste. And what that'll do is it'll automatically type in the 41, 0.079, 3 for me. If you don't have those prompts, you can just type those numbers in with commas in between them. The comma's right above the number 7. And when I hit enter, it's going to give me the probability that I get exactly 3 successes. The probability is 0.2304. And we will always round probabilities to 4 decimal places, 0.2304. what is the probability that in my survey less than the expected value carpool to work? In other words, we want the probability that x is less than the expected value, which we found in part B was 3.293. Well, this is a discrete distribution. You can't have 0.293 people saying, yes, they commute to work. So what we're really saying is the probability that x is less than or equal to the number 3. And it's important to identify what it's equal to, less than or equal to, not just less than. Because in the CDF, when we do the cumulative distribution, we need to know what number to start at. So now we're going to do the binomial CDF cumulative distribution, which is going to add from 0 all the way up to 3. Starting with 41 is the sample size. 0.079 is the probability. And we're going all the way up to 3. We'll hit second distribution to the bottom, but this time selecting the binomial CDF. I have 41 trials. 0.079 is my probability, and my x value is 3. And when I hit paste, it's going to put those numbers in for me. Again, if you don't have the prompts, just put those numbers in separated by a comma. And when I hit enter, it's going to tell me the sum total of all the probabilities of 0, 1, 2, or 3. There is a 59.17, or a 0.5917 probability that if I ask 41 people, I will get 3 or fewer carpoolers as they commute to work. Let's do one last example as we wrap this video up. We want to know, what is the probability more than 4 carpool So now I'm asking for the probability that x is greater than 4. The problem is the CDF counts down. So this would be a lot of work to do to find them individually. The probability of 5 plus the probability of 6 plus the probability of 7 all the way up to the probability of 41. That is a lot of work. Instead, what we're going to do is we're going to use the complement. We're going to find out the probability that we're not talking about and subtract that probability from 1. 1 minus the probability that x is now less than or equal to. And we have to decide what number we're less than or equal to count everything that's not included with the greater than 4. The blue greater than 4 does not include the number 4. So in the complement, we do want to include the number 4. If our probability statement had equality, if it said or equal to 4, then we would have to do the complement, which is the opposite, and to not include 4, and so we'd start at 3. So you really have to be careful to decide what you're going to include. So now on my calculator, we're going to do 1 minus. We want less than or equal to 4. That's the binomial CDF, cumulative distribution function, so it goes up to. With the 41, 0.079 probability, we're going to go up to and include the number 4. 1 minus second distribution up to the binomial CDF. We still have 41 trials. We still have 0.079, but now we want the x value to be 4. Paste. And when I hit enter, 1 minus the binomial CDF gives me a probability of 0.2205. So there's a 22% chance that we would have more than 4 out of 41 workers carpooling to work. That's the binomial distribution. The calculations we'll have the calculator do for us, but we do need to know how to set them up, how to find the mean and the standard deviation, and interpret what pieces are talking about what parts of the binomial. So take a look at a few on your assignment. Come to class ready to discuss it further, and we'll continue to investigate the binomial distribution.